Notes, Part 2, Take 7. In the previous video, you filled in the front side of your notes learning about solutions. You're getting reminders from Chapter 2 and about molarity, what it means. At the bottom, it talked about the formula, and this formula is what we're going to use to tackle 8 questions on the back side. Friendly reminder, anytime you're substituting for volume, it must be in liters. So milliliters have to be kicked into liters. So these are typically 2 or 3 mark questions. You're expected to show a formula, numbers with units, and a final answer. I know in physics, often you don't have to put units. But I find in chemistry, if you put in units, you really can confirm in your own mind if you've done it right. So C equals N divided by V. Here's our N, our moles. Here's our V already in liters. And we get 0.35 big M calcium chloride. So I expect to see number, units, and identify the chemical. Number 2, same kind of game. N equals C times V, concentration times volume. Here's our concentration, here's our volume, and we get 1.59 moles of sodium hydroxide. Number 3, we're going to use the same formula. But the curveball was, this was in milliliters. So we immediately have to kick into liters. Please don't use a calculator for that. Just go 1, 2, 3, move the decimal point 3 to the left, and you'll have your volume. You multiply through, and this was a case of a perfect 5. Your calculator price said 0.1875. We had to chop the 3 sig figs, so the 5 rounded that up, the 7 up to an 8 to make the even number. Number 4, now it wants volume, so there's our formula for volume. Here's our 1.5 moles, and here's our 0.125 M. It's a good idea to try to visualize what's going on. This is saying if we had 1 liter of this solution, it would have 0.125 moles. But we need to get up to 1.5 moles, so we're going to need a fair amount of volume of this. And in this case, it's 12.0 liters. Of course, if you just wrote down 12 liters, you are not respecting sig figs, and marks will disappear. Number 5, 6, and 7 are still going to use the NCV formula, but they're also going to be asking you to remember how to convert between mass and moles. So 5 and 6 and 7 are all 2-part questions. So we are given a mass, and we're given a volume, and we have to get a concentration. If we're after concentration, we know concentration is N divided by V, but we don't have moles directly. We've got to convert our mass to moles. So that's our first step. We have a molar mass, so we can do that conversion. And that's what you're seeing there. We get a tiny number of moles, and now we're off the races. We have that moles, and we have this volume. That volume's in milliliters. We need to get that in liters. And that's why we've converted to 0.0120 liters. And we get a low concentration of KMnO4. That nice purple stuff. It'll stain a little bit. Number 6 is going the other way. We're given a concentration of volume. That means we can get our moles. And our last step will be asking to get the mass. This thing's already in liters, so that's very nice. So we multiply through. And we go 0.6 of 2.50 is 1.50. And we take that moles, multiply by the molar mass of KSCN, and we get 146 grams of KSCN. So the pain in the keister of 5 and 6 is you need molar masses. Number 7, when you look at a question like this, it's saying, how would you prepare this? This is something we always are doing when we're setting up labs. It'll tell us to make a certain volume and a concentration. Really what it's asking you is find the mass. And so it's like number 6, but we're going to have to describe things in words later on. So first thing, C and V are going to be used to get our moles. This is in milliliters, so we have to convert it to liters, proper sig figs. And impressively, we get exactly 1.00 moles, well, with some degree of uncertainty. Now we take that moles and we convert to mass. Molar mass of CaOH2 is 74.10, And so when we multiply through, we get 74.1 grams of calcium hydroxide. But we haven't answered the question fully, because now it wants you to make a sentence describing what you did. So we're going to take that 74.1 grams calcium hydroxide, we'll put in a beaker, and then we're going to add sufficient water to get a total volume of 500 mils. So you put it somehow like this. I would dissolve 74.1 grams of calcium hydroxide in enough water to bring the total solution volume up to 500.0 milliliters. And every year I get people who do the calculations perfectly, and then they forget to put a sentence in, even though I leave lines for it. Number 8 turns out to be an incredibly straightforward question. Important in this section on the mole, important in solutions, and really important next year as well. It wants to know the concentration of chloride ions in this solution, 750 mils of water. Now, aluminum chloride is soluble. So what we have to do is we're going to have to get our concentration of solute from our volume and concentration. Notice 750 mils becomes 0.750 liters. So we're starting with 0.400 big M AlCl3. So that's the first step. Now the second step is we have to do a dissociation equation. This is our dissociation equation. Aluminum chloride, when you throw it in water, it splits into aluminum 3 plus and 3 chloride ions. Using a bit of what's called stoichiometry that'll come up in chapter 6. We have 0.4 here, 1 to 1, we get 0.4 there. Don't really care about it, but we do care about the chloride, 1.20 M. If I had 1 particle of this aluminum chloride, I'd get 3 particles of chloride ions. So whatever number I have here, I just multiply by its coefficient, and that gives me the concentration. And that is the answer that I put right in there. And square brackets are used to represent concentration. So we love our abbreviations and symbols. They save a lot of writing. Square bracket chloride means the concentration of chloride ions. And then we put in our number with our units. All right, take 7's the charm. Finally got this one done and buried.